Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 4 exam for February-March 2021. So let's get started. Question 1a says figure 1.1 shows a piece of glass of thickness 2.0 centimeter and area 0.15 meters squared. The density of the glass is 2.6 times 10 to the power of 3 kilograms per meter cubed. We have to calculate the weight of the piece of glass. So weight is equal to the mass multiplied by the gravity field strength. And we can calculate the mass as density multiplied by volume. And here the volume can be calculated as the area multiplied by the thickness or the height. And then we multiply by g. So we have 2.6 times 10 to the power of 3. Then we multiply by 0.15 and then by 2. But we have to divide by 100 to convert from centimeters to meters. And then g is 9.8. That gives an answer of 76.44, which we can approximate to two significant figures according to the numbers in the question. So we write it as 76 newtons. Part B says the piece of glass shown in figure 1.1 is used as the vertical viewing window of an aquarium. The atmospheric pressure outside the aquarium is 1.0 times 10 to the power of 5 Pascal, and the average pressure on the inside of the aquarium window is 1.3 times 10 to the power of 5 Pascal. Calculate the resultant force acting on the window due to these pressures and state the direction in which it acts. So we have the equation force is equal to pressure multiplied by area. Or we can say that the resultant force is equal to the resultant pressure or the difference in pressure multiplied by the area. So we can say that we subtract 1.3 times 10 to the power of 5 minus 1.0 times 10 to the power of 5 to get the difference in pressure. And then we multiply by the area of the window, which was 0.15 meters squared. That gives an answer of 4,500 newtons. And the pressure on the inside of the window was greater than outside, so the resultant force would be toward the outside of the window, so it would be outwards or pointing to the outside of the window. Part C is about barometers and manometers, so you can skip this part for the new syllabus. It says figure 1.2 shows a vacuum pump connected to the top of a vertical tube with its lower end immersed in a tank of liquid. The pump reduces the pressure above the column to 0 and the pressure at point X is 9.6 times 10 to the power of 4 Pascal. Calculate the density of the liquid. We can use pressure is equal to rho GH. So here we have 9.6 times 10 to the power of 4 is equal to the density, which is unknown, multiplied by 9.8 and then multiplied by 12. So we can move this part to the other side by division. That gives an answer for the density of 816.3265 and so on. So we can approximate this to 816 or 820 to two significant figures. And the unit for density here is kilograms per meter cubed. Question 2AI says state what is meant by the moment of a force about a point. It is the turning effect of the force about a point. So this is the definition of any turning effect or any moment. Part I says figure 2.1 shows a large crane on a construction site lifting a block of mass 14,000 kilograms, and we have a distance of 20 meters from point A for the weight of the block to act at point B. Calculate the moment about A due to the 14,000 kilograms block suspended from B. So moment is equal to the force multiplied by the perpendicular distance, and the force here is equal to the weight. So we calculate mg and then multiply by the distance. So we have 14,000 multiplied by 9.8 and then we multiply by the distance, which is 20. That gives an answer of 2,744,000 Newton meters, which we can write to standard form and to two significant figures as 2.7 times 10 to the power of 6, and the unit is Newton meters. Part BI says speed is a scalar quantity and velocity is a vector quantity. State the difference between a scalar quantity and a vector quantity. We can say that vectors have magnitude and direction, but scalars have magnitude only. I says write down one other scalar quantity and one other vector quantity. For the scalar, we can say that we have mass or distance, time, density, energy, power, any one of those. And for vector quantities, we have displacement. Also, we have acceleration and momentum and moments and forces. Part C says figure 2.2 shows two forces acting on an object. Draw a scale diagram to determine the resultant force acting on the object and state the scale you use. We have 20 newtons and 30 newtons, and we have a lot of space here, so we do not draw 20 as 2 centimeters and 30 as 3 centimeters. That would be a very small diagram. So we can multiply 2 by 2 and 3 by 2 to get 4 centimeters and 6 centimeters. And now if 20 newtons is represented by 4 centimeters, 1 centimeter would represent 5 newtons. So this is our scale here. We write 1 centimeter to 5 newtons. And since the diagram is already drawn as the two forces acting from the same point, we can mimic the diagram and continue as a parallelogram, since the forces are acting from the same point. And the forces are pointing downwards and to the right, so we start our diagram from the top and from the left side. We can start by the easy one, which is vertical, and we can draw it as this. And then we draw one line 4 centimeters long to represent the 20 Newton force. And then we use the protractor to measure the same angle as the one drawn here, which is 60 degrees from the bottom and to the right. So we adjust the protractor from the top of the line that we've done and move it this way and mark the 60 degrees on our paper. Now we use the ruler again to draw the other line with the correct angle, but we have the distance here now is 6 centimeters, so we draw a line 6 centimeters long like this. And now we have to close a parallelogram. For this I'm going to use a compass. We are going to measure the distance of the first force. So on this diagram the distance here is 4 centimeters, and I'm going to move the compass to the other side. So we've measured the length of this vector. We stand on the other vector with the compass to draw a curve here like this. And now we measure the length of the other force as 6 centimeters, and we move the compass to the other end of the other vector, so we can draw another curve that intersect with the first one like this. And now we can join the lines. We draw the first line from the end of the first vector as dashed lines because these are not the original vectors. We move to the other one. We draw the last line 4 centimeters, and we draw another dashed line to the intersection point. And now we draw the resultant from the starting point of the diagram to the ending point of the diagram. So from this intersection, a diagonal to the other intersection, and we draw a solid line and measure the length. Here we have the length is approximately 8.8, but not all of you will get the same exact drawing. I'm gonna write here 8.8 centimeters for the resultant and mark the arrows of the diagram. So we have one arrow here like this, and we have a double arrow here for the resultant and an arrow here for the other vector. And I'm gonna label this as the 30 Newton force and this one as the 20 Newton force. And now we have our drawing. Now we write the value of the magnitude of the resultant force. We have the measurement and we have the scale. We multiply the measurement by the scale. We have 8.8 times 5. That gives an answer of 44 newtons. And for the direction of the resultant relative to the direction of the 20 Newton force, that means that we are required to measure an angle. So we place the protractor at the intersection between the resultant and the 20 Newton force, and we measure the angle between the two lines here. This is approximately 36 degrees. Not all of you will get the same exact angle, but I'm going to write the one that I've measured. So writing here 36 degrees. Question 3 says a power station burns waste materials from farm crops to generate electricity. State and explain whether this process is renewable. It is renewable, and that is because we have a continuous supply, because crops can be regrown, so there is a continuous supply of energy. Part B says the power station uses some of its waste thermal energy to heat water for houses in a nearby town. State one problem of using waste energy in this way. If the power station is far from the town, we can say that heat will be lost on the way to the town, and suggest a way of reducing this problem. To reduce energy losses, we can use insulated pipes or containers to transfer the water to the other town. Part C says state two environmental consequences of burning coal to generate electricity. We can say that emissions of polluting gases affects the environment, or we say that carbon dioxide causes global warming, increases the temperature of the surface of the planet. Question 4a says, in terms of the momentum of molecules, explain how a gas exerts pressure on the walls of its container. First, we say that gas molecules move randomly and collide with the walls of the container. When they rebound, the change in momentum exerts a force over the area of the container or the container walls, and that's what causes the pressure, because change in momentum over time is equal to the force, and force over area is equal to pressure. Part B says a fixed mass of gas of volume V1 is at temperature V1. It is compressed to a volume V2. I says complete the equation for the final pressure P2 of the gas when the gas is compressed at constant temperature. So the original equation is P1 V1 is equal to P2 V2. And then we need to make P2 the subject, so we divide by V2. So P2 is equal P1 V1 over V2. Double I says, state and explain how the final pressure compares with P2 when the temperature of the gas increases during the compression. So it will increase or will be greater because as temperature increases, molecules gain kinetic energy and collide harder and more frequently with the walls of the container, exerting a greater force on the walls of the container. Question 5a says, state the name of the reflection of a sound wave or ultrasound waves. That would be an echo. So echo is a reflection of sound. Part B says, figure 5.1 shows an ultrasound wave being used to scan an internal organ of a human body. The ultrasound wave has a frequency of 2 MHz and passes through human tissue at a speed of 1500 meters per second. Calculate the wavelength of the ultrasound wave in human tissue. So wavelength can be calculated as the speed divided by the frequency, and we have the speed 1500, and then we divide by the frequency, which is 2 times 10 to the power of 6 for megahertz. That gives an answer of 7.5 times 10 to the power of -4 meters. Part C says figure 5.2 shows crest of a wave from a point source S approaching a straight barrier. On figure 5.2 indicate and label one wavelength. So that would be the distance between two wavefronts. So this is one wavelength. We can write the symbol lambda for wavelength. Double I says on figure 5.2 draw 3 crests of the wave reflected from the barrier. Now we at first need to know the point of the reflection. So we draw a line which is perpendicular to the barrier, 90 degrees to the barrier here or the wall here, starting from S, and we measure the distance to the barrier. That is approximately 3.1 on my diagram. So we measure double the distance to the other side and mark the position of the center. So at this point approximately. And now we use this point as the new center of the waves, and we use a compass to draw the reflected waves. And we can start with the one hitting the wall right here, and we draw a curve on the same side of the original waves, but we have to make sure that the distance between the wavefronts is the same. So we again measure the distance between the wavefronts. That is approximately 1 centimeter on my diagram. So we repeat 1 centimeter apart. On your diagram it can be another number. So this is a part of the next wave and this is a part of the next wave. Now we use the compass again, but we extend from the same center of the compass but increasing the length, and we draw the next wave like this. Now we extend the length again from the same center to the next point, and we draw the next wave like this. So this is the final shape of the diagram. Question 6a says figure 6.1 is a full-scale diagram showing a converging lens, the two principal focuses f1 and f2, and an object PO which is pointing downwards. On figure 6.1, draw two rays from O of the object to determine the position of the image, label the image IJ, and measure the length of the image. So we have two rays. The first one is parallel to the principal axis here. So we can measure the length of this arrow and measure the same distance on the dashed line at the center of the lens to mark the point where we can connect the parallel ray. And we draw the ray using a ruler like this. So we have the first ray here. And from this point, we draw a line that passes through f1. But since the object is in between the focus and the lens, that means that we will have to extend the ray backwards. So we take that into account from the start. Now we adjust the angle of the ruler and then we draw a line that is as long as possible because we do not know where the intersection will be, but it will be down here on the right side. So we draw a straight line, solid line on this side and extend it backwards. The second ray is a ray that passes through the optical center, and then we extend it backwards again from the top of the image. So we adjust the angle of the ruler like this. And then we're going to do the same thing. We are going to draw a long line forward and backward. So we have the ray going to this point, but we extend the ray backwards like this. And the back side of the rays should be drawn as dashed lines. So we are going to erase some parts of the rays extensions backwards. Now the intersection point of the rays is the point where the image of O is formed. But O is the tip of the arrow or the head of the arrow, so this is also the head of the arrow here. And the tail of the arrow is actually on the principal axis. So the arrow is pointing this way. And the object is labeled PO, and we are required to label the image IJ. So this point here is I, and this point here is J. So this is the final shape of the diagram, but we have to label the directions of the rays of light. So this is the original ray direction, and this is the original ray direction from the ray that was parallel to the principal axis. So this is the full shape of the diagram. Now we are required to measure the length of the image. So using the ruler here, shorten it a little bit, and we measure the distance from the principal axis to the intersection of the rays. On my diagram, this is approximately, it is between 2.9 and 3. It is closer on my diagram to 2.9, but you don't have to get the same exact number. I'm gonna write the one that I've measured, which is 2.9 centimeters. Part B says ring 3 descriptions of the image. This image is the same way up or down as the object, so it's upright, and it is made of intersection of rays, so it is virtual, and its size is larger than the object, so it is magnified. So it is not diminished, it is magnified here. This is the first one. We ring it. It is not real, it is not the same size, it is the same way up as the object, it is not upside down, and it is virtual. Part C says figure 6.2 shows 3 rays of green light passing through glass blocks. 3 rays of red light approach the glass blocks on the same path as the rays of green light. On figure 6.2, draw the path of these rays of red light to the right of the glass block. So red light actually bends less than green light, so they will be further apart and intersect to the right of the original intersection direction. So we can start from this point and draw towards the first prism, and from the same point towards the other prism, and extend these rays a little bit like this, and we draw the refraction inside the prism on the top one and on the bottom one. So we have less bending for the red light than for the green light. And we draw the arrows again here. But the middle one is incident at 90 degrees at this point and 90 degrees at this point, so it keeps moving forward in the same direction. Question 7 says, figure 7.1 shows a horizontal conducting wire XY between two opposite magnetic poles. Wire XY forms a circuit with an ammeter. Explain why the reading on the ammeter is 0 when the wire XY is not moving. We can say that the wire is not cutting the magnetic field of the magnet, or we can say that there is no change in flux in the wire. Part B says the wire XY is moved and there is a deflection on the ammeter that indicates there is a current in the wire from X to Y. On table 7.1, tick one box to indicate the direction of the movement of the wire XY and explain your answer. So using the right hand rule, we have the direction of the current to the right from north to south, so using the index finger pointing to the right, and the current is moving from X to Y, that is into the page, so the middle finger points into the page. Now the thumb is pointing upwards, so the direction of the motion will be not out of the page, not to the left, not to the right, not to the bottom, it is to the top of the page. So we take this one and we explain how we use the right hand rule. So using the right hand rule, the index finger meaning magnetic field to the right, the middle finger into page meaning current into page, and thumb meaning motion is upwards or towards the top of the page. Part C says state what is observed on the ammeter when the wire XY is moved in the opposite direction. So we have current in opposite direction and in the same direction as part B, but at a greater speed, so higher or greater current. So the current increases as speed increases. Question 8a says define electromotive force or EMF. That would be the energy supplied by a power supply or a battery to move a unit charge across a complete circuit. Part B says figure 8.1 shows a source E of EMF 60 volts in a circuit, the heater H of a resistance 22.5 ohms, and the potential difference across it is 45 volts. So we have here 45 volts and 22.5 ohms. Calculate the power of the heater. We have voltage and resistance. We can use power is equal to V squared over R. Voltage squared, that is 45 squared divided by the resistance 22.5. That gives an answer of 90 watts. Double I says the potential difference across the resistor X. Now resistor X and the 10 ohm resistor are all in parallel but in series with the heater. So the voltage of the power supply is divided across the heater and this part together. They both have the same voltage, which is the difference between 60 volts and 45 volts. So we subtract these voltages. We say 60 minus 45. That gives an answer of 15 volts. Triple I says the current in the 10 ohm resistor. We have the voltage 15 and we have the resistance 10. So current is equal to voltage divided by resistance. So we divide 15 by 10. That gives an answer of 1.5 amperes. Question 9 is about logic gates, so you can skip this question for the new syllabus. Part A says write down the truth table for an OR gate. So we have two inputs, input 1 and input 2, and we have one output for the gate. And the possible inputs are 0, 0, 0, 1, 1, 0, and 1, 1. And for an OR gate, whenever there is 1 in the input, the output will be 1. So only 0 and 0 will give 0 and all the other inputs will give 1s. Now draw the symbol for a NOR gate. It is the same as an OR gate, so it is drawn like this, but with the circle at the output part. So this is the output side. And we have two inputs here, so we label them inputs like this. Part C says figure 9.1 shows a digital circuit designed to produce the values shown in table 9.1 for the output S from the two inputs P and Q. Table 9.1 is the truth table for the circuit shown in figure 9.1. Complete the column for the point R in the table, which is the output from a NOT gate from input Q. So it reverses the input Q. So 0 will be 1, 1 will be 0. Same here and here. Double I says state which type of gate is used for gate X. Explain your answer. So gate X has the inputs P and R and output S. So we compare these two inputs with the output. So 1 and 0 that gives 0, 0 and 0 gives 0, 1 and 1 gives 1, 0 and 1 gives 0. So only gives 1 when the inputs are both 1. That would be an AND gate. And we write the reason. It only gives output 1 when both of its inputs are 1. Question 10a says state the proton number, nucleon number, and the value of the charge on an alpha particle. So for proton number, we have 2. Nucleon number for an alpha particle is 4 because it has 2 protons and 2 neutrons. And the charge is positive 2e, where e is the charge of 1 electron, which is the same as proton. And we have 2 protons, they are positively charged, so it is positive 2e. Part B says a nucleus of strontium-90 consists of 38 protons and 52 neutrons. Strontium-90 is radioactive and decays by beta emission to an isotope of deuterium. The symbol for strontium is Sr and the symbol for deuterium is Y. Write down the nuclide equation for this decay. So we start with Sr. We have the proton number here 38, and adding 38 to 52 that gives us 90. And we decay to another nucleus Y and a beta particle, and the beta particle you should memorize it has a nucleon number 0 and proton number -1. So 0 means that the nucleon number does not change, so it is 90 for Y, and we add 1 for the proton number, so it will be 39, such that 39 minus 1 gives us 38. Question C says the half-life of radon 220 is 56 seconds. A sample of radon is in a container. After 112 seconds, the mass of the radon is 9.2 milligrams. So we have the half-life and we have the total time of the experiment and we have the final amount of the nuclide. Calculate the mass of the original sample. So going backwards in time, we do not divide by 2, we multiply by 2. But first we need to know how many half-lives have passed. So we divide 112, which is the total time, by the half-life 56. That gives us 2 half-lives. That means that we will multiply by 2 times. So from 9.2 going backwards in time times 2, that gives us 18.4. Going backwards again times 2, that gives us 36.8. So the answer here is 36.8 and the unit is the same as the one in the question, milligrams. So this was the end of the exam. I hope you enjoyed this video and found it useful. Keep practicing and I will see you in another video.